In this section 3.3, we're going to cover division of polynomials, the remainder, and the factor theorems. So first thing that we're going to start doing is dividing polynomials using the process of long division. So we're going to start with this problem here. So to divide polynomials using the process of long division, the first thing, there's a couple of two things that we have to keep in mind. Number one is that the polynomial must be written in descending order of the powers, and rule number two is that the polynomial must contain all the powers of x from the highest to the smallest. So in this polynomial that we're given here, 8x to the fourth power plus 16x cubed plus 2x to the second, we are missing a couple of powers. This polynomial doesn't have an x, so that means we have to add a 0x, and it doesn't have a constant, so we have to add the constant. Okay, so we're gonna set up the division as a regular long division. So it would be, I'm just gonna put it a little bit lower. It would be 8x to the fourth power plus 16x to the third power plus 2x squared plus 0x plus 0. So what we gotta do is we're gonna divide it by the polynomial 2x squared plus 3. Now, to perform the division using what we call the long division, the first thing we have to do is, just like with the regular division, we're gonna divide out the first terms of this polynomial. Okay, so that would be 8x to the fourth. We're gonna see how many times of the 2x squared goes into 8x to the fourth. So basically divide them out, and that gives you 4x squared times. So that one is gonna be my quotient. So that goes to the top of the division. Next step in the process is that we need to multiply this times the numbers in front of it times the terms on the outside, which is times the divisor. 4x squared times 2x squared is going to be 8x to the fourth power. You have to align it under the same power inside. So the fourth power is going to go under the fourth power. Then 4x to the second times 3, it's going to give us 12x to the second. So you have to align it under the 2x to the second. So we're going to have a 12x to the second power right here. Then the next step in the process is that you have to subtract. Just keep the following in mind. When I subtract, in reality that means change the signs. So if I change the signs and I combine like terms, then we're going to get 8x to the fourth minus 8x to the fourth cancels out. Negative 2x to the second power minus 12x squared is going to be negative 10x squared. What is the next step in the process? You're going to bring down the next, the terms right here to the bottom. So it will be 16x cubed minus 10x squared plus 0x plus 0. Now we're going to keep repeating this process until we cannot divide anymore, and that happens when the degree of the dividend is less than the degree of this divisor, which in this case it is still bigger, so we can divide a couple of more times. So we're going to divide out the first terms again, which is these two. 16x to the third power divided by 2x to the second power, that is going to be 8x. So that goes on the top, that is my quotient. And then we have to multiply. 8x times 2x squared is going to be 16x cubed. You have to put it under the x cubed. 8x times 3, it's going to be 24x. So you have to put it under the 0x. Then we're going to subtract. And subtract, we said what it means. It means change the signs. So when I combine these, 16 minus 16 is 0, so they cancel. 0 minus 24 is negative 24x. And then we're going to bring down the other two terms. So we're going to have negative 10x squared minus 24x plus 0. Now you see that the powers here of the divisor and the dividend, they're exactly the same. So that means we can divide one more time. It's only the first terms. Negative 10x squared divided by 2x squared, it's going to give us negative 5. Okay, So that's going to go on the quotient right here, and then we're going to multiply. Negative 5 times 2x squared is negative 10x squared, so we have to put it under the x squared. Then negative 5 times 3, it's going to be negative 15, so we're going to put it under the constant, which is the 0. Then we're going to subtract, which means change the signs. So though both of them are negative, so right here that's going to become a positive, and right here that's going to become a positive. So then, what are we going to get? Negative 10x squared plus 10x squared cancels. 0 plus 15 is going to be positive 15, and then we're going to bring down the negative 24x. And basically, we cannot divide anymore because the power of the dividend is smaller than the power of the divisor. This is when we stop. So, how do we write the answer? This is how. You're going to write the answer for the division that we got on the quotient right here at the top, which is 4x to the second power plus 8x minus 5. And after that, we have to put the remainder. The remainder, we're going to express it as a fraction because that's basically what the remainder means, a fraction. So it's going to be negative 24x plus 15 over the divisor, which is 2x squared plus 3. That is the answer for this division. Okay. So the next thing we are going to do is going to be for the next problem, and now I'm going to show you how we can divide using the next process, which is called synthetic division. Okay, so this is the one that is going to be the most effective and the best one. We're going to be using this one to find zeros of polynomials in the next section, and also starting on this section. Okay, so the first thing that we got to do on the synthetic division is well, before actually I go over the synthetic division, there's one little fact that you need to know about the synthetic division. Okay, this one, it can only be used when dividing by a linear factor. This is mostly what we're going to be using the synthetic division for, when we're dividing by x to the first power. Okay, that is basically the key here. So the first steps in the process of synthetic division is basically the same thing. We need to make sure we arrange the polynomial in descending order. That should be the first thing we should do. And not only that, we also have to make sure we include all the powers of x from the highest to the smallest. So x to the fourth is the first term, then minus 3x cubed, then it's going to be the plus 2x squared, then the minus 6x, and then we should have a constant. Then that is going to be divided by x plus 3. Now let's go ahead and get started to set up the division. So on the synthetic division is going to work a little bit differently than the long division. So what we're going to write inside of this division is only the coefficients of the variables and the constant. That's all we need to place in this division. That's all we're going to need. So the coefficients are 1, negative 3, positive 2, negative 6, and 0. Okay. And then on the outside of this division, first thing we have to do for the x plus 3, we have to equal it to 0. Your divisor, you equal it to 0 and you solve for x, and that gives you x equals negative 3. So we're going to place a negative 3 on the outside. And the process goes as follows. First, you're going to bring the first number all the way to the bottom of the line. Then you are going to multiply the number on the outside, which is your divisor, times every number that you get on the bottom line. So negative 3 times 1 is going to give you negative 3. You're going to place that on the next column inside. Then what you're going to do with those numbers inside, you're going to add them. Negative 3 plus negative 3, it's negative 6, and you put the result on the bottom of the line again. Then you're going to keep repeating this process. Now you're going to multiply the negative 6 times the negative 3 again. That's going to be a positive 18. Then you put it on the next column, and you add these numbers inside. That's going to give you a 20. Then you're going to multiply that 20 again. 20 times negative 3 is negative 60. If I add it to negative 6, that's negative 66. Then negative 66 times negative 3 is 198 plus 0, it's going to be 198. So this last number is going to be your remainder. So when I write the answer for the synthetic division, this is basically what the answer is going to consist of. This is my division right here. Just keep the following in mind. Anytime I use synthetic division to divide, the degree of my new polynomial, it's going to be 1 less than the degree of the original polynomial. So my expression is going to be 1x, but instead of the 4th power, it's going to be 1 less, 3rd power. Then we have a negative 6, so we're going to put a minus 6, and this one is going to be x to the 2nd power. And then we're going to keep on going. The next one is a plus 20, and that one is going to be my x to the 1st power, and then the negative 66 is my constant. And then for the remainder, we're going to write it the same way. It's going to be the remainder divided by the divisor, which is x plus 3. And this is the answer for this division. However, since the first coefficient is a 1, I don't have to put that coefficient of 1. There is 2 main applications of synthetic division. One is going to be the remainder theorem. Okay, so the remainder theorem states the following: that if any given polynomial f of x is divided by x minus c, then the remainder is f of c. That basically means f of c means the y value when x is equal to c. And when you're dividing with synthetic division, remember you have to solve for x, which gives you that same x equals to c. So what is this telling you? It's telling you that the remainder is the same thing as the y value when x is equal to that number c. Okay, so that's basically what the remainder represents. So if we go back to the previous question right here, when we divided by x equals to negative 3, that remainder of 198 is the same number that we would get if I replace that x equals negative 3 into every x of this polynomial. And that, remember, when we replace the x, that will give us the y value when x is negative 3. Okay, so what we are going to do next is an application, of course, which is the synthetic division. What we want to do is use the synthetic division and the remainder theorem to find the function value f of negative 3. This is what we are looking for in this question. So the first thing that we gotta do is make sure that the polynomial is written in descending order, which in this case, if we look at all the powers, x cubed, x squared, x and the constant, everything is already in descending order, and all the powers of x are in the polynomial. So what I'm going to do is write the coefficients, which is 3, negative 6, negative 5, and 7. And this one is already solved for x. That one is x equals negative 3, so negative 3 on the outside of this division. So what we are going to do is first we're going to bring the 3 all the way to the bottom of the line. Then we are going to multiply this number on the outside times the number at the bottom. So negative 3 times 3 is negative 9. We place it in the next column, then we add the answers here, which gives us negative 15. Then negative 15 times negative 3 is positive 45. Then we're going to add them right here. 45 minus 5 is negative 5 plus 45 is going to be 40. Then 40 times negative 3 is negative 120. When we add it to 7, it's going to give us a negative 113. So this remainder, remember, represents the y value. That's what the remainder represents. So right here the question is find f of negative 3, which means find the y value when x is negative 3, and that y value is negative 113, which is my remainder. Remember that the remainder represents the y value at that specific value of x. With that said, what would you tell me if the y value at a given division is equal to 0? Then that would mean the following. If we get a y value of 0, that means that x that we divided by is an x-intercept of the function. So in other words, the original expression that we divided by, we can say automatically that it is a factor of the polynomial. That is my next definition, which is going to be called the factor theorem. The factor theorem states, let f of x be a polynomial. If f of c is equal to 0, then x minus c is a factor of the polynomial. In other words, if we divide the polynomial by that expression x minus c and the remainder is 0, that means that the x minus c is a factor, and that means that x equals to c, it is a 0 or an x-intercept of the polynomial. Okay? So we're going to use the synthetic division from now on to actually find the zeros of polynomials. Let's work out the next problem. So we're going to work out this one right here. It says, solve the equation 12x cubed plus 16x squared minus 5x minus 3 equals to 0, given that negative 3 halves is a 0 of f of x equals to 12x cubed plus 16x squared minus 5x minus 3. So they want you to solve the equation. Solve the equation means find the solutions or find the zeros of this equation. To find the zeros, again, we're going to use synthetic division now that we know what synthetic division does. Now, we know already that one of my zeros is going to be negative 3 halves. So what we're going to do is, using synthetic division, we are going to factor that negative 3 halves from this polynomial equation. 12, 16, negative 5, and negative 3. You see that everything is in descending order, and all the powers of x are included in this polynomial, all the way to the constant. So, first thing we're going to do here is that we're going to bring the 12 all the way to the bottom of the line. And then what we have to do is multiply this number times the bottom number. So when you multiply times a fraction, this is the way we do it. 12 times negative 3, it's negative 36. Then you divide the negative 36 by 2, and that gives you a negative 18. Then you're going to add them. Negative 18 plus 16 is negative 2. Then you're going to do the multiplication again. Negative 2 times negative 3 is positive 6. 6 divided by 2 is going to give us a 3. Then we're going to add them. Negative 5 plus 3 is negative 2. Then we're going to multiply it again. Negative 2 times negative 3 is 6. Divided by 2 is going to give us a 3. And then negative 3 plus 3, it's going to give us a 0. So, if the remainder is 0, that means that the y value is equal to 0, which means that it is an x-intercept, and that's what we were told, that this is a 0, which means an x-intercept of the polynomial. Okay. So, what's going to be the next thing? The next thing is that after we do synthetic division, remember what happens, the degree of the polynomial decreases 1. So, my original degree was x to the x to the third power, so this is going to become 12x to the second power minus 2x minus 2. This is what is left out of the polynomial after we did the synthetic division. So guess what we can do now? Since this is a quadratic equation, based on what we learned in section 1.5, we can now solve this equation by either factoring or by using the quadratic formula. First of all, I'm going to try to factor. If factoring doesn't work, then we're going to go to the quadratic formula as my second resource. So, for factoring, the first thing we need is check if there is a greatest common factor, which in this case, there is a 2 as a greatest common factor. So we can factor a 2 from this polynomial. So if we factor the 2, then we are going to be left with 6x squared minus 1x minus 1. Now, this is a trinomial, meaning that we have to factor it by multiplying a times c. 6 times 1 is going to be 6. So we need to find two numbers that when multiplied, they give me 6, and when subtracted, they give me a negative 1 as an answer. And those factors will be 3 times 2, but negative 3 and positive 2. So we're going to open the two parentheses. We're going to have an x on each one. Then the two factors, which is negative 3 and positive 2. But on this polynomial, since a is equal to 6, then remember we have to divide both factors by 6. Since none of them can be divided by 6, then we gotta reduce this. Okay, so with that fraction 3 over 6, we can simplify it by 3 right here, and that gives us a 1/2. So we're gonna have a 2 parentheses x minus 1/2, and the 2 and 6 we can divide them by 2, and that's gonna give us a 1/3. So that gives me x plus 1/3 equals to 0. Then what we have to do, solve for x. Oh, by the way, remember that I'm gonna do this. So whenever you end up with a fraction, you have to put the x, the denominator in front of the x. So that's gonna end up as a 2x minus 1 and a 3x plus 1. The last thing you would do is solve for x. So you would equal each one of these factors to 0, and then you solve for x. So if I solve for x, that's going to be a positive 1. So 2x equals to positive 1, and then divided by 2. So that gives me x is equal to 1/2. This one, I subtract 1 from both sides, so that gives me 3x equals negative 1, and then divided by 3, that gives me x is equal to negative 1/3. But wait a second, there were supposed to be 3 solutions, because it is the power is x cubed. Well, wait a minute, we already know that we were already given one of them, which is negative 3/2. So my third solution is the one that we were already given, which is x equals to negative 3/2. So these are the solutions, or the zeros, of this polynomial equation. And this concludes section 3.3.